switching gears a little bit and talking about AI and energy. You probably all have heard that the predictions are that AI is going to take an increasing share of the electricity supply in the U.S. and elsewhere in coming years, growing rapidly. This is on top of, after decades of relatively flat electric use in the United States, as efficiency improved and we were able to get along with existing generation sources and existing transmission. And that era is over because of new uses like AI, because of the global drive to transition energy sources towards more electrification of everything from building heating and some transportation to traditionally hard to decarbonize industries. So globally and in the US, we have a need for a lot more energy. How do we, in that situation, how do we make sure that there's a reliable, resilient supply of electricity for AI? How can AI uses and data centers more generally, including Bitcoin mining centers, but also more general data centers, how can they be good citizens on the grid and serve their customer needs and the broader needs of the energy sector? So, Greg, can you start telling us what Siemens does in this space?
And thank you very much, and thank you to Mara for doing this. If you haven't looked at what Mara has as its key mission statement of energy, compute, and digital capital, talk about a great area for them to look at U.S. competitiveness. As this panel is entitled, how can U.S. competitiveness work in an era of AI when it comes to energy? And Siemens has been dedicated for many years to figure out the best way to provide electrification across our customer base, but especially in the United States. As you look at our ability right now to electrify critical parts of the country and critical infrastructure and assets, never has it been more of a focus than it is right now. From government to industry to academics, everyone is focused on electrification. And we hear a lot about the impact of AI on power, the impact of AI on the need for water to cool different data centers. But the great thing about it is it's going to usher in a powerful new focus on making our grid in the United States so much more resilient. As you look at the ability to power AI data centers, we look at the ability to have distributed energy for these centers, so that when you build a data center, you build the power that goes with it, whether it is a combined cycle plant that uses natural gas, combined with renewables, combined with battery technology, the power to put that data center somewhere, to create jobs, to create the necessary infrastructure to support the local community is phenomenal. The investment, the power, and the technology is all there, and it can really extraordinarily impact the ability of the United States to be competitive, the ability of the United States to get at the heart of AI, and more importantly, can help the local communities, which quite honestly, if you look around the country, have struggled for a number of reasons, whether it's power generation, whether it's transmission, which our grid is woefully inadequate. We need to do a lot more on transmission. But the great thing about it is it will allow for these data centers, when they have excess capacity, when their power is greater than their need, they can push that back to the grid. And that's an extraordinarily exciting and optimistic thing that we see.
Thank you. Ram, you want to tell us about what LG Nova does in this space?
Yeah, thank you again, Mara, for inviting me to this panel. I think it's an exciting time to be working in the energy space. I run the energy program incubation efforts for LG Nova, and LG Nova is an incubation arm of LG looking to build software-enabled solutions and launch it into the market as a separate business. Recently, we launched a company called Pado Energy, focused really around energy orchestration, particularly for data centers, but also broadly for the large C&I markets. They've been working with Mara to provide solutions that can enable and disrupt the data center market. And obviously, as you know, we're in an unprecedented time in terms of what's happening in the AI world, both in terms of innovation on the AI side, but also if you look at the energy demands that are growing in the AI later to AI. Today, I think Goldman Sachs recently reported about 14% of the compute in the data center is all related to AI demands, and then that number is within the next 2 years is going to nearly double. And so innovation is the key right now. Everything from cooling and how it's actually managed within data centers to how load is actually managed, how different infrastructure and assets are optimized and operated. It's not going to be just one solution and technology that solves it all. We need a hybrid of variety of technologies. And then in addition to that, a lot of innovation on the grid side as well. Better ability to predict actually how power flow is going to be on the grid. Modern technologies to determine what power carrying and load carrying capacities of these transformers are, and power lines are, so that you can actually optimize and utilize it even more effectively. All of that is really changing the innovation world right now.
Great, thank you. Jayson, we heard a little bit this morning from Fred about how Bitcoin mining can be a flexible load. Can you tell us a little more broadly about where the mining centers fit into this data center picture and how they can play a role both in being available for demand response, which is an important strategy in making optimal use of the energy system, but also how else where they're the same and have the same general issues, and where they're different from general purpose data centers?
Yeah, I'm grateful to be on this panel and appreciative of the opportunity. Yeah, so some of the attributes that differentiate traditional AI HPC data centers from Bitcoin mining data centers, one, which is extremely valuable, is flexible baseload. So being able to ramp down hundreds of megawatts of power within 1-2 minutes, being able to provide that back to grid operators. You've seen this play out in Texas during storms where we've been able to keep communities power on by reducing our power usage. Another is Bitcoin mining in particular doesn't use water. We use a dielectric fluid, a mineral, to immerse our machines, so we're not pulling that water from where it could be used by local communities. And the third is modular. We don't need fiber optic cable. In fact, most of our data centers are in shipping containers. And so it is one of the few industries that is flexible baseload that can be moved to wherever that power source is. And so when most of my comments will be around regulatory and policy conversations that we're having around these key issues, but when you think of innovation and competitiveness, which some of my panels have mentioned, those are a lot of the conversations that we're having in Congress right now. And if I could just give a few examples of this. In the UAE, we have a partnership with the Sovereign Wealth Fund, ADQ, where we have a 250 megawatt facility there, where we monetize the excess energy during the winter, and then during the summer months we power down to give that back. In Finland, we 2 of our data centers actually use heat reuse, so we heat 11,000 homes in Finland right now. And then the third piece to that is we are now having our own power generation. So we just bought a wind farm in West Texas that was not able to be monetized appropriately because of the subsidies that were ending. But we can use some of our older machines that we would have in fact retired to actually make that wind farm profitable. And so we've moved our older machines there to mine Bitcoin when the energy is less or more affordable than it would be otherwise. But these are certain things that I think will be part of larger conversations that we'll be having in Congress.
Great, thank you. So you've raised the issue both of some international aspects here and more broadly, all of your comments have brought into my mind some of the questions about siting. So what can you tell us, and I guess we'll start with Ram this time and then Greg and Jayson, about where data centers can be, where they should be, both in the U.S. and globally, and what is the location of these centers? How does that affect our role in U.S. the U.S. competitiveness angle of the AI market?
Yeah, one of the beautiful thing about data centers is that if you look at, especially the modern data centers, the power in a rack has continued to grow dramatically, which means that the rack density and the power densities have gotten to the point where a single rack could be a megawatt of power, and so it essentially allows for approaches what Mara has already done in terms of their solutions for crypto mining, where it's modular, scalable, can be deployed very fast. And so I think that the entire market is transitioning to that. That allows for essentially, from a design standpoint, the data centers can be really installed and operated anywhere in the U.S. But the critical thing, obviously, is going to be power and power needs and where the availability is. And it's a combination of not just, as I said, one technology. As you know, if you're preparing for an Olympic sport, you're not just going to have one type of runner. You're going to have a sprinter, a marathoner, and an ultramarathoner. Energy market is no different. You need actually technologies that are fast to respond, can actually really turn on and off really fast, as well as deliver power and energy when it's needed rapidly. And then you need actually marathoners like solar and wind and storage that can provide for multiple hours, anywhere from 4 to 10 hours. And then ultimately you need an ultramarathoner, which is really where gas assets and nuclear SMRs and other solutions can play a role. And so in terms of the locations, really I think that if you're looking all over the U.S., we have a lot of places that strategically that these data centers can be really deployed, and then I think that that's why you're seeing places like Arizona. There's a rapid growth in the data center market. I think water is still an important factor to be considered, and so in terms of positioning and all that. But I think even there, I think the data center technology itself is rapidly evolving, where hopefully that we'll have less and less use of water, and ultimately maybe better solutions that don't generate as much heat, and therefore maybe we can go with just two-phase liquid cooling or other approaches that don't require a lot of water.
And Greg, what is Siemens seeing in this space?
And thank you, Professor. And Ram, I absolutely agree with what Ram said. You can put a data center anywhere. It's how you plan for it. I think that the best way to look at data centers and where they should be sited should be, where can you find a local government and state government partner who will help you navigate the regulatory hurdles, the permitting hurdles, but more importantly, help you build an integrated campus. Really good example. Up in Michigan, we work closely with some folks up there, and they are going to put a data center on a 1,300-acre tract. They're going to have a rare earth mineral recycling plant. They're going to have a number of other industries that come in there, whether it's manufacturing, data centers, services, and they're going to have an integrated campus. And as part of that campus, they're going to have the ability to make their own power. That's an extraordinary way to look at data center siting, because you not only want to have it where you have the ability to get the power, get the water that you need, but you also want to have the ability to cross-sector. And Ram mentioned this earlier today about having the ability to make sure that the sectors that are involved in, whether it's Bitcoin mining or it's production of rare earth minerals or it's the creation of jobs in the service sector, how can you ensure that the energy you're getting is meeting the sector need at the most affordable and the most quality of power? I mean, a good friend of mine is here, John Klein, who's one of the foremost experts in government power. How does the government relate to this? How does the government become part of the solution across these sectors? And what that does, it not only creates the ability to get the energy you need, but it raises up the level of resiliency of that community. And more importantly, it creates jobs, whether it's tax incentives or it's siting incentives or it's permitting incentives or it's navigating through the local utility and interconnects. The government has to be part of this. And so that's how I would approach it.
Jayson, you can tell us both about where you see the Bitcoin mining centers goes, but also I know you're very involved in these discussions about the how the government regulation can support this kind of flexible development and multi-generator development that Ram and Greg have been talking about.
Yeah, and some very key points I want to hit on, which Greg mentioned around relationships with communities. We see this also at the community and state level, the federal level and in the international level. Many of the investments that we've made internationally have been through government partnerships specifically. But also, I just want to, and also the taxes that we pay in the community investments. Stacy is in the audience. You should say hello to her. She's our community manager. All the community investments that we make in these local communities where lots of times there was industry, but the industry is left for whatever reason, and Mara and Siemens and LG and others have come in to invest in these key areas. But one thing that I will mention on sort of being agnostic, particularly for Bitcoin mining specifically, is, with some of these traditional AI and HPC data centers, you need, a significant amount of megawatts to train these, these large language models, less so on the inference side. But for Bitcoin mining, we don't have to have, we can have something small and we have some medium, something large. And so a lot of the conversations that we've had with government, with the federal government and the state government is on these stranded assets. You might have been here earlier, Patrick Witt, the executive director at the White House, talking about private sector companies partnering with the governments. We do flared gas on oil fields, and so we capture that methane that's being burnt and then run it to power our data centers. And so that's doing a lot of things that maybe a traditional AI HPC data center wouldn't be doing because of the how small the footprint is, or they're spread out in geographically dispersed locations. And that's an area in particular that Mara has been sort of on the front end of with flared gas, and then also on hydro as well. Where we partnered with the Paraguayan government and actually run our data centers on their hydro facilities. And so those are, I think, two keys that differentiate us a little more than maybe your traditional AI HPC.
Great. Okay, one more quick question before we move on to another topic. So with these growth curves that we're seeing, the predictions, now, of course, I prefer attributing it to Niels Bohr, the physicist, but prediction is difficult, especially when it's about the future. But if AI stays on the kind of growth curve it is, we're hearing about needs for gigawatt scale data centers, or at least there are plans to build several hundred megawatt data centers in many places. How do we power that stuff in the short term? Longer term, people are talking about SMRs. MIT and others hope maybe we'll actually have some small fusion plants running in the early 30s. But these things are all, probably early 2030s before we have first few of a kind, much less have them widely available. And gas turbines, which is the current go-to, 3 to 4 year backlogs. So what do we do for the next few years to power this expansion while taking care of all the other electricity we've heard about, and not doing what if those of you who may have seen the lead New York Times article yesterday, what's happening in Mexico and Spain and some other places, which is the data centers are turning off the power and taking the water from communities.
I think Jayson pointed out, I think we've got a lot of stranded assets today in the market. We've got actually a lot of excess capacity, actually, if you look on the distribution side as well as on the transmission side, that we can't really use them because they're not available all the time. And so building flexible solutions, even on the data center side, where it's more distributed, where you can actually take that excess available capacity and being able to really operate and efficiently bring the data center online quickly is one of core areas that we are actually at LG Nova. We've got an incubation that we're working on how do we actually do through software innovation, bringing actually excess capacity that might be available in various parts of the grid. And so there's a lot of now new startups that are looking in this space quite aggressively. In addition, as I mentioned, I think if you're only going towards one solution, that if it is gas, it's going to take a lot of long time. But if you combine with a lot of different resources, I think that time can be reduced. In addition to that, I think a lot of the modeling tools around digital twin and how to actually model transmission and how grid can be expanded, hopefully can also bring down the timeline, because today, if you look at the permitting, it can go up to 5-6 years before a large data center comes online. And it's really because of the multiple lines of reliability that they're looking for. Whereas utilities now are starting to put together proposals where they say if you're willing to take 90% availability and manage rest of the 10% yourself, then we can actually bring power capacity faster. So those are some approaches where you can actually bring data centers online faster.
And that's a really excellent point that Ron made about digitalization. The great thing about what digital can do for us today and what software can do for us today in the energy market is it allows us to do simulations. Ron talked about the digital twin. The digital twin is a virtual representation of something in the physical world. The great thing about it is, and Siemens does quite a bit of this, is before you build a factory, before you build a data center, before you build a grid, you can simulate it once, you can simulate it twice, you can simulate it 10,000 times to see what is the most optimal way to ensure that that center gets the power that it needs, but also the local community is not impacted. It may be when you use dispatch technology through software to determine when should I focus on renewables, when should I focus on gas and combustion, when should I focus on batteries, and how can I optimize that so that the amount of power that you have can meet the needs that you have. There's also another thing that we often look at too is there are mobile capacities for power. So for example, you'll see a number of companies create mobile gas turbines that, yeah, they're not the permanent solution, but when there is a problem, you can bring in a 30, 40, 50 megawatt mobile power solution with a substation and power something in a temporary way. So as you look at peak shaving, you look at the ability to dispatch, you look at the ability to make sure that when you're executing on an AI project, maybe you pick a different time to do it. One of the things that we see on high performance computing is the ability to tackle demand based on the timing of when it is cheaper to do it from a cost perspective in the cloud, but it could also be that way for energy as well. So I think software-defined modeling, simulations, and digitalization of the grid and the assets will make this problem a lot less difficult.
I think you've already told us a little bit about your location and stuff, so let's move on to the next one, and I'll let you take it first. If we start thinking about these flexible assets and being able to put things in so many places, and you've already mentioned putting some of them in places other than the U.S., we get into the question of first of all, the U.S. economic position, but also questions about this really becoming part of critical infrastructure. But we heard this morning, if Bitcoins become more part of the financial infrastructure, the data centers are handling all sorts of sensitive data. So that certainly sounds like critical infrastructure to me. What are the security issues? To what extent are those issues complicated, or maybe should it even be a barrier to, okay, so you're shifting your data center loads, why not shift them overseas? And for that matter, what if it's cheaper and faster to get a new big data center up there? What are the key issues to you in terms of security of this and reliability of it as a component of our critical infrastructure?
For the Bitcoin network, in particular Mara, I think, and probably more broadly in the energy sector, is more manufacturing here in the U.S. That's been one of the key bottlenecks. A lot of that stuff has been outsourced overseas. In particular, our Bitcoin mining data centers, a lot of those are actually developed in China. And in fact, 3 of the largest Bitcoin mining ASICs manufacturing are Chinese, including Bitmain. And so one of the key things our CEO did was invest in a company called Auradine, which is the first U.S.-based ASICs manufacturer in the world, in California. And so it's and he sits on the board of that. And so that's one piece to it, which is to create innovation here in the U.S., stop being so reliant on other countries to produce the things that we need, that we say that it's important and valuable here in the U.S. And then the second, I think, is an education piece, which is something that Mars also continues to do, which is educating policymakers. I think in all the conversations that we've had so far, a key important thread is education and advocacy, and ensuring that policymakers who are making these decisions, whether it's at the federal level or the state level, whether it's at the PUC or ERCOT, that they understand all these unique technologies. They get a bunch of stuff in every single day, and it's important on us to educate them on why it's important to invest in these things.
Great. Greg, so from Siemens' perspective, and I know you've done a lot of work on DoD energy systems, what do you feel about the criticality and security issues?
Oh, thank you, Professor. And to me, one of the things that we miss quite frequently when you think about security as it relates to energy is operational technology, cybersecurity. Now, operational technology, everybody's very concerned about their email and their bank account getting hacked, right? I remember vividly a couple of years ago sitting in a gas line in Washington, D.C. because the Colonial Pipeline was down for 8 hours. Think about it when it comes to data centers. I heard a general officer recently at the Pentagon tell a group of industry leaders, a human can live 3 days without water. A data center can live 3 hours. Understanding the ability to ensure that our water systems, our power systems, the ability to ensure our fuel systems have resilient cybersecurity measures in place, operational technology, the things that operate what we use and live by, is absolutely essential. And one of the things that Siemens has really focused on, and a lot of our critical infrastructure companies do this, is how do we make sure that our most important systems for survival are properly secured. And so for what we do, we think that operational technology, security, and cybersecurity is absolutely essential as you build out these data centers, as you build out the ability to ensure that the local community has their electricity, the local community has their water and power. I think what this data center and AI boom can do is raise everybody's awareness and also raise their level of security and resiliency by implementing these great measures that already exist in the marketplace.
Great, thank you. Ram?
I think Greg hit on it spot on in terms of actually covering a number of topics.
Okay.
I would just say that I think that any technology when it's brand new, there's always a growth curve it goes through, and there's going to be some pains associated with learnings and improvements. But that doesn't mean that we really stifle innovation by continuously stopping around every challenge that we face. We definitely have to think about, cybersecurity. We have to think about, equipment reliability, resiliency, how to make sure that, key assets, including energy, water, data, all of that is really secured. But I think a lot comes from also diversity, right? I think that, how do we actually have redundancies, portfolio of solutions, being able to really quickly come back up even if something goes offline. All of that becomes really, really critical, and that's where the innovation really needs to happen.
Great. Okay, so final question for all of you. We'll go down the line from Greg. We have a little less than a minute apiece. Jump forward 10 years. What does success look like for AI, for energy security, for American global competitiveness? And what one big, bold step do we need to take now to assure that we get to that success?
And that's a great question. And like your physicist friend, I'm always terrible at predicting the future. But what I think that the one big thing we can do right now is invest in the grid. I think we have to, as a nation, focus on the ability to produce power in distributed means around the country. We unite around a community-based portfolio, very similar to what Jayson and Ram talked about, where we have government, we have industry, we have the local community all working together. We ought to have the ability to have this distributed energy at multitudes of places, whether it's a hospital, a university, a municipality. We need to have distributed, resilient, and redundant systems. And I think the great thing about AI is that so much is being invested in it, and so much is going to be focused on getting those data centers to be resilient and capable with extraordinarily quality and resilient power, that all the boats are going to rise as the tide rises. All the capabilities that we need for a nation to succeed are going to happen. And I think if I were going to do something right now, I would invest heavily now in the grid, and then I would be ready, as Jayson said, to have modularity, where you have the ability to have a small modular nuclear reactor as they come online, or you have the ability to have fusion, as the professor said, where you can integrate it without having to change the grid. Make the grid the operating system that you can add in the tools.
Great, thank you. Ram?
I think as Roosevelt said, future belongs to those who believe in the beauty of their dreams, right? I think that we should all be dreaming about how our future should be and make that happen and work hard towards it. AI has tremendous potential to actually change everyone's lives in terms of actually making it better in many ways. Already we're seeing that, advances in medicine, advances in, research, and all of that is accelerated through a lot of these capabilities. And really, if you tactically ask what would success look like, I think if we have these data centers, these infrastructure capabilities that can come online even within 6 months, that would be wonderful in terms of actually our ability to move fast. I think in terms of success, us as a nation, we're able to export a lot more. We're able to manufacture a lot more of these critical items, including some of the things that we are putting efforts towards today. I think all of that can be actually viewed as success.
Great. Jayson?
These are great answers. Flexible baseload, I think is what I would say is probably the most important thing. Bitcoin mining in particular has been leading on that front, but you now finally see AI and HPC companies that are starting to come around to that fact as well.
Great. Thank you all.
Thanks.